Hello there. I just got a email request today about what dilutions were and a bit of help, and so I thought in between classes I might be able to squeeze in one of these videos and try and upload it and see if I can give you a hand. Dilutions first deal with solutions. Solutions are when you'd have something like sugar and maybe you take that and like dissolve it in a little bit of water. It's kind of cheesy, sorry. But so you've got a solution in here that would be sugar mixed with water, and that solution is dissolved in there. And the idea behind a dilution is when you're going to change that concentration. So the question I have written here is list ways that you could change. I would go through with the class and say, what are some ways you could change the concentration? People would tell me that they could add more sugar, which is an excellent idea. It doesn't deal with dilutions, but that's one way. It's tough to take sugar out, though, so that is one that they sometimes come up with that doesn't work. You can't really take sugar out. You could, however, very easily, another answer I usually get is to add water. And you could very easily add water, and that would change the concentration of the solution. It would be not as strong if you added more water. It wouldn't taste as sweet. You could also try and take water out, but by taking water out, you can't take out the sugar. So the only way you could take water out really is by heating it or letting it evaporate. You could boil out some of the water and that'd leave the sugar behind. That would make it stronger. So this would make it weaker, and this one here would make it stronger, and this method here would also make it stronger. So there's ways that you could change that. What does it mean then? The next question I usually get into is what does it mean when something's diluted? Well, when something's diluted, it means that it's getting weaker. You're watering it down is the way we say the common thing. So diluting it is watering a solution down. Watering it down. You're changing the strength of the solution. And usually, the dilution formula also works if you evaporate water out, but it's commonly that you're adding water to something and making it less, making the concentration less than what it was. So when we do that, if we were to add water to this and the water level would then raise and be up to here, the question then that I ask you is there any more or less substance, which is the solute, dissolved in that water, which is the solvent? Is there any more sugar in there? No, all we added was water. So clearly no. So that means that the mass of sugar is the same. Well, if the mass of sugar doesn't change, then the moles of sugar also doesn't change. So we have same moles as well. Well, this is where we start to get to the formula, the point of the question, because the number of moles of a substance is given by concentration times volume. That comes from the formula I give to my students, that C is N over V, moles per liter. That's a molarity. So some formulas may have a big capital M over here for the C. I use concentration, that's what I'm sticking with. So the number of moles would clearly be the moles per liter times liters, and that would leave moles when you're done, right? So that seems to make sense. We could say that N is C times V. And if you have the same before and after, then before we make the change, you would have Ni is Ci times Vi. But after the change, you'd have to have the moles after is still its new concentration times its new volume, right? After you added water, the concentration has gone down, but the volume has gone up. But what the key to the dilution formula is that you did not change how many moles of sugar are there. And so the crucial part of this is the fact that your beginning, if moles before is the same as moles final, initial and final, then the CI-VI before is the same as CF-VF after. It has to be the same because it's the same amount of sugar there. So that's where the relation comes from. Take a quick check on my time. Lots of time. So if we look at an example now, and the trick, I guess, when you're doing these examples is to figure out which is your beginning volume, which is your final volume. That's the only thing, and it requires a little bit of literary skills, I guess, because sometimes it gets to be tricky. This one I think is straightforward. Water is added to 200 mils of a 2.4 mole per liter ammonia cleaning solution until the final volume is 1 liter. So they were very nice by telling you final volume is 1 liter. Down here for VF, I will put 1 liter. The water is added to, so this is what I started with, 200 mils. It's going to be very useful to have those units be the same, so I'll divide it by 1,000, and it'd be 0.2 liters. The beginning concentration, the stuff you added water to, it was initially 2.40 moles per liter, so my I stand for initially. This is my beginning concentration. My final concentration, the molar concentration or molarity, is what we're trying to find out. So the formula that the person had emailed me about had M's in it, as what is this MI, VI, MF, VF, or M2, V2 thing. All right, so what it is you got your initial and concentration and volume before. When you multiply those, should be exactly the same number as afterwards. So we're looking for CF. We're going to rearrange our formula. Rearranging, we'll take VF down and divide. CI, VI, divide by VF. That's what my final concentration is. So my initial concentration is 2.40 moles per liter. My initial volume is 0.2 liters. And my final volume is 1 liter. And that's how we would get our final concentration. The liters are going to cancel out, and it will leave moles per liter afterwards. Okay, so 2.40 times 0.2 is 0.48. Divide by 1. You're not using a calculator for any of this, right? 0.48 moles per liter is CF. Of course, you don't use the calculator here, right? Point means you move the decimal one place and then double it. So we can do that stuff pretty easy. I don't want to get too preachy about mental math, but anyway. If we look at our second example, again, I'll just quick check for time. It's 2.5 minutes or so. A student is instructed to dilute some concentrated HCl. So you're starting with a concentration of 36%. And you want to make it go to make 4 liters. So my final volume is 4 liters. And you want a 10% solution at the end. Notice that your final concentration has to be smaller because you added water to it. You diluted it. So your beginning volume had better be smaller because when you add water, it's going to get bigger, right? We're looking for VI. Starting with the same, CI-VI equals CF-VF. Trying to solve for VI, the CI goes down. So it's CF-VF divide by CI. So we take our CF, which is 10%, times the final volume of 4 liters, and divide by 36%. Well, what's nice here is we don't got to get hung up on the units. As long as they're the same, the percent weight to volume is going to cancel out. So you've got 40 over 36 liters. Well, that's 10 over 9, reducing the fraction, which is 1 and 1/9. Your calculator will tell you that's 1 with a whole bunch of 1s. So 1.1 liters would be the answer that you could write, depending on where you want to round that off. So I hope this helps you out a little bit. I got to get ready for my next class, so good luck with that.